recorded. So if you miss anything, please do check back, and you should be able to recap everything. So Kevin, if you're ready, I'm going to go ahead and switch presenters and let you share your screen.
Right. All righty. Let's see. All right. It says I have been made presenter. Show my screen. All right. So now you can see on my email in the background there. Start this. How is that coming through?
1 second. Mine's still loading. There we go. It's
okay.
Good for me.
All right. Great. I appreciate that check. I always like to, have somebody who's actually watching the seminar let me know how things are going. Well, again, Rachel, thanks so much for inviting me to present. I really appreciate it, and
Sure.
have had such great experiences with you guys in the past. So it's always a pleasure to be able to present with you from Pragmatic Work. So thanks for inviting me.
Thank you.
All right. And just to tell you a little bit about myself, and I don't want to spend too much time on this, but my first professional job in the data management arena was for NASA. I was a contractor, one of the high-tech contractors that NASA hires to do different work, and worked on the International Space Station back in the 80s, worked on Baxes and early versions of Oracle. From there, I went to the U.S. Army Missile Command, spent a few years working on Oracle and things like that. Wrote my first book when I was there at the U.S. Army Missile Command as part of I was trying to multitask some of the work I was doing on my master's degree, which I never finished, but I did finish my first book there. And,
Kevin, we're having
I went to Deloitte and Touche in Nashville, Tennessee.
Kevin, I'm sorry to interrupt, but we're having a few complaints about your audio. It's a little broken up and not very clear.
Uh-oh.
Sorry, it's fading in and out, and it's a little hard to hear you.
All righty. Okay. Is it coming through all right?
Yeah, that's much better.
I don't know why that would be. And this is the slide I want to spend the least amount of time on, too. Yeah, when I was at Deloitte, managing database systems there, and was part of the original team that started the Professional Association for SQL Server. For those of you who are in the attendance and you haven't yet taken a look at SQLPass.org, or you haven't heard of perhaps the Pass Summit, I really strongly encourage you to take a look at this organization. It's a wonderful organization, very heavy, very high-end learning available for you for free on the website, lots of streaming video. And of course, the Pass Summit is the biggest and best known of the SQL Server conferences. Over 3,000 people come every year. It's a fantastic event. But just to hurry through that, after that I went and joined Quest Software, where I'm currently serving today. Been there almost 10 years as a product architect. Became a SQL Server MVP during those days. If you've ever heard of Toad, that's one of my products. And I've written a lot of other books over the years. My best known book is SQL in a Nutshell, and that's me if we've never had the pleasure of meeting in person. Now, just a quick note, if you are looking for free goodies, I write lots of posters for Quest throughout the year. So if you, over the past few years, written several posters, this is the current one, the Perfmon counters of interest. So if you've ever heard of Perfmon and you want to get to know it better, I encourage you to get that poster for free. It's about 14 years of my experience kind of distilled in one poster, with great contributions from other people like Brent Ozar and Bob Ward, who's the head of the Microsoft support team for SQL Server, Christian Bolton, and a whole bunch of other Microsoft certified masters. And there's quite a few other ones. We also have some free DVD training that includes me, Buck Woody, Brent Ozar, and some other really top talent. So what we're going to talk about here today is, I really wanted to make this idea of internals, what happens inside of SQL Server, kind of funny and fun, which, Rachel, you mentioned you'd never seen a talk on the internals. One of the things I wanted to do was for someone maybe who really didn't even have a SQL Server background. Internal sounds like something you're going to fall asleep over while somebody drones on about, some kind of strange database, really high-end database, stuff that PhDs talk about. So Instead of that, we're going to drop some acid here. We're just going to get crazy. We're going to do all kinds of stuff about internals, and we're going to look at it as if it was a, we're going to take a guided tour, maybe like imagine you're walking on a walking tour, or maybe you're with a bicycle courier and you're delivering letters. And just a quick note, much of the source material came from the book from a friend of mine, and very talented Microsoft Certified Master over in the UK, Christian Bolton. This is his book, and I highly recommend it. So first thing we're going to do, we're not actually going to drop acid. That was, of course, just a joke. And we're not talking about hydrochloric acid. What we're talking about here is something called the acid properties of transactions. And if you've ever taken a look at kind of database theory, you'll find that the acid properties, this is an acronym, and this is something that applies to all the major relational databases. Oracle, SQL Server, IBM's DB2, MySQL, all of those use this to describe the major characteristics that their databases and their transactions must support. The first part of that acronym is atomic. And this, if you've ever taken chemistry classes, you'll know that, in chemistry there are compounds, which, for example, you might have a compound like steel, stainless steel. And this contains many different elements in it. And then that might be broken down into molecules. So there might be a molecule for the specific elements, for the stainless steel itself. It's got chromium, it's got iron, it's got carbon. It has all these different things that compose those molecules. And then when you get to the atomic level, if you break it down any smaller than a chromium atom, or iron atom, it loses the characteristics that make it iron, or carbon, or chromium. And so a acid transaction can't be broken down any further than it already is. It is entirely itself. And if it gets any smaller than that, broken down anymore, it loses the characteristics that make it what it is. Another aspect is that these transactions are always consistent. So imagine we've got an ATM, and how would you like it if you walk up to an ATM and you put in your card, ask for $100, and today we might get $100 out, but tomorrow we might get $98 out. That wouldn't be good. Nobody would like that. So what we need to do is we need to take steps to ensure that no matter what is processed, it always processes the same way, consistently, every time. It also has to be isolated. That is, that the transaction that happens does not affect anything else besides its own transaction. So imagine I went up to the machine and I said, I want $100, my ATM machine, and that's actually two transactions. One transaction that takes out $100 from my account, and another transaction that puts $100 into my hand. But if something happened, let's say, what if it took a little bit of money out of my savings account instead of my checking account? That would bleed over. It means it's not isolated in the way it needs to be. And so that is unacceptable. And then finally, and perhaps the element that adds the most overhead altogether for transactions in a relational database is durable. So if an ATM is hit by lightning and I'm trying to take out $100 and it doesn't actually record that operation so that when they get that ATM back up and running, the bank would be very unhappy that the machine might have given me $100, but they haven't been able to record it. So one thing you might remember about a transaction is that it is either all or nothing inside of a relational database. It either applies entirely or it doesn't get applied in any way whatsoever. And that one aspect, durability, is probably the biggest amount, it causes the biggest amount of overhead in behind-the-scene processing. So we're going to talk about what happens in the relational engine, and these acid properties are extremely influential on the way these engines, the relational database engines, are designed. Incidentally, if you've heard of NoSQL databases, or maybe you were active with MySQL back in the days when it was very popular as a brand new kind of database for these websites, one of the reasons why it was so popular was because it was fast. And that's the same thing can be said for many of the NoSQL databases They're very fast. And what do they do in order to ensure that they're so fast? Well, they don't do these acid properties. They do not ensure durability, isolation, consistency, and so forth. So, for example, Cassandra, which is used by Facebook, is eventually consistent. It's not immediately consistent like the relational database. Some of the other drivers for some of the architectural things that we will see inside of relational databases are just stuff that makes it go faster, or performs more powerfully, more scalably. Some of the things we'll see in there are designed to maximize hardware, particularly from back in the old days when hardware had a great deal of difficulty keeping up with all the transactions and the data processing that was asked of it. So things like caching are a way of maximizing the hardware, because hard disks, for example, have to get up to speed. They have to spin up. And so if they're not currently spun all the way up to speed, it takes a lot longer to write those transactions than if they are. So let's cache all of those transactions so we have a lot of transactions to send at one time back to the hard disks. And then finally, there's quite a few features inside of SQL Server that are there simply because another major database platform has them, and so we have to stay competitive. And we'll start to go through some of these. Now, I mentioned a minute ago that I wanted to make this kind of funny and fun, and one of the things I thought I would do was I'm going to lay this out like it was maybe we've got a tour guide, or maybe, and so the character I thought would be, let's use Dr. Sheldon Cooper. If you've ever seen the Big Bang Theory TV show, it's a really funny sitcom here in the USA, situation comedy, and this character is brilliant, but somewhat socially inept, and so he's a great character. And he actually, just as an aside, on his bookshelf you can see he has a book on SQL on his bookshelf. So what we've got here is we've got all these major areas inside of the inside of SQL Server. There's the relational engine, the physical parts like the transaction log and the data files, and then there's the storage engine that controls how things are put to the data files, the transaction log, and how things are handled in memory. And then we have the protocol layer that addresses how all of that is communicated between the end user and the engine. So okay, we're done, right? That's all you need. Just kidding there. What we're going to do is we're going to start with Sheldon, and he's going to take us through the process. We're going to start with the process of a select statement, just a read operation inside the SQL Server. And so imagine you are sitting at your desk and you want to do something that involves a relational database. And this is specific to SQL Server, but in general terms, it actually works for all the other ones too, say Sybase or Oracle. So some of the very specific elements might change from relational database to relational database, but in general, this is what's going to happen. First thing that happens is, let's say you sit down at your computer, maybe you're using a website, maybe you're using a client-server app inside of your company, and let's say you're going to use one of the travel websites, so you want to book a flight. So you pull up the website. After you're logged in and whatnot, you say what city you want to fly from. And this is a lookup. It's got to look up and make sure that there actually is an airport at that city and with the right code. So it takes that city name or code and it wraps it up using the tabular data stream. So these are called TDS packets, wraps it up, and it uses one of the protocols. Typically, you're going to use TCP/IP, but there's a few others that you might use. And it uses the SQL network interface layer, or a SQL network interface, to use TCP/IP or whatever protocol you choose to package that up. And it's sent over, through the ether over to the server, which typically, if it's using TCP/IP, is going to pick up that language event, and it's going to unpack that set of packets, and it's going to start to look at it. And so imagine these are buildings we're going to. So we started over here, we've driven through this building, took a little time, now we're at this building. And the first thing that catches it after the TCP/IP port 1433 is the command parser right here. And what does a parser do? The parser chops up it examines the language that's sent to it grammatically. So if we sent to it, say, a select statement, but what it says instead of select is it says S-L-E-E-C-T, it would say, I don't understand what that is. I'm going to throw an error because that's not part of the grammar I understand. But if it opens it and says, oh, select, that is a language event that I can understand. So now what I want to do is I want to see if this language event that you are asking me for has already been processed recently. And so I'm going to look for that in the plan cache. The idea is if we can find it right here in the buffer pool, we don't have to, again, imagine if we're driving through a town, we don't have to go over here to the optimizer, to the query executor, and elsewhere. We can just go straight to the buffer pool to get the plan cache in the buffer pool to get that language event as it's fully optimized. So we're going to take a look and see if there's basically the same or a reusable form of that SQL statement in the plan cache. If there is, that saves us a lot of time. But if there's not, we have to take a bump over to the optimizer. And the optimizer is kind of the crown jewels of most all the relational database systems. This is where a lot of the intelligence and a lot of the programming smarts are kind of stored. And we need to build a query tree for the optimizer to decide how it is going to break apart this SQL statement, the select statement, and get your results for you. So what it's going to do is it's going to take a several-step process to figure out, sorry about that, several-step process to figure out what will be the most efficient plan for you to get your data back. Now notice I said the most efficient plan, not necessarily the best plan. What do you think the difference might be between the most efficient and the best plan? Well, the answer to that is that SQL Server and all the other relational database systems, they use a cost-based method of determining which execution plans to use. And so it's only given a certain amount of time, a very specific amount of time, about a half a second actually, to figure out what is the most efficient plan. And what that means is it's going to look for the best plan, the least expensive cost plan in a half a second. Whatever that is, that's what it's going to try to use. It goes through a four-step process. The first step is called pre-optimization, in which it produces just a super trivial plan, select everything from a table. That would be a trivial plan. Then it goes to what's called phase 0. This is where it might do very simple nested loops, and these are called transactional processing plans. In phase 1, so these are more CPU cycles. It will use a quick subset of the entire query processing rules that it has available to it that has the most common patterns, things like a simple equi-join or simple where clause. That's a quick plan. And then finally, you go all the way to what's called a full plan, in which it might do things like parallelism. And it says, hey, maybe there's indexed views I can use. So it's looking at all kinds of different ways to do things. And so this can be an expensive part of the operation. And again, if we can, it'd be great if we could avoid that and actually just pull it straight out of the plan cache of the buffer pool. But assume we didn't get to do that, so Sheldon had to take a little trip over here to the optimizer, spend a lot of time getting that figured out. Now, once that query plan gets calculated and built, it's handed over to the query executor. And I don't know why, but I initially read this as executor, and who, of course, is a person who executes criminals and things like that. And then I thought, no, this is the executor, which is a person who acts on someone's last will and testament. And either way, I came away feeling kind of morbid. But yeah, so the query executor takes that set of operations that it was given in the query plan, and it wraps that up into a little OLADB package, kind of a proprietary internal little package, and it hands that off to the storage engine. And the storage engine is where all of these kind of memory and CPU-based operations up here are turned into the reality of physical files and data pages in either somewhere in the buffer pool, either in the data cache or plain cache. So that little OLEDB packet handed over to the storage engine, which picks it up under the access methods. And if you've ever looked at a query plan inside of SQL Server, you will probably remember that there's some stuff that's not in parentheses and stuff that's in parentheses. Or if you just use the graphic plans, there's the stuff that you see at the top when you hover over a box, and then all these really detailed things down at the bottom. So it might say something like, maybe it says something like an inner join, but then at the bottom it says, left semi-inner join. What is that? Well, that kind of information is how the access method turns these kind of logical operations, like an outer join or something like that, into a physical operation that actually happens on the disk. Now, also notice that there's a little area here that is blanked out. It says Transaction Manager. But since we're reading and not writing any operation, we don't have to use this at all. So what SQL Server again says, just like we did up in the area in which we optimized the query, once again, SQL Server says, hey, where does this data reside? If it resides, if it's already out there in the buffer pool, in memory, which is anywhere from 16 to 30 times faster than disk, before any reads are done, even for that matter, just by its very nature, it's so much faster. Hey, can we get that from the data cache instead of going out to the disk and retrieving it? And if the answer is yes, then it's going to answer that select statement immediately. But if the answer is no, SQL Server has to go to the data file, the database itself. And one thing I know that I have been guilty of misstating, and other people, well-known speakers have misstated as well, is sometimes we will use the term, we'll say something like, well, that's when SQL Server has to go directly to disk to get what it wants. And that's actually a misstatement. SQL Server never does anything directly to disk. It, in fact, always goes to disk and then has to load that data into the data cache up here. And then it manipulates that information however you need in the data cache. So nothing ever happens directly on disk. It's always going to be in the buffer pool. So it will load that data that is requested by your select statement into the buffer pool, the data cache of the buffer pool, and then that information will then get retrieved to you sitting at your desk. And that's kind of the life cycle of a select statement. We're going to go through the life cycle of a write operation in just a minute. So let's talk about a couple things now. Just going back to this, let's say there's 40 or 50 people that are trying to do this work all at one time. How does SQL Server decide who gets what, who gets which order, and all of those sort of things? That is handled by SQL Server using schedulers. And so what happens with the schedulers? In general, it's kind of first come, first served. And I like to use the analogy of going to you're in a shopping, let's say a grocery store, and you're going to buy some groceries. And, well, this is no good. I was going to say the CPU is kind of like a cash register, but we're in the 21st century. Let's get a real, there we go. That's much better. So we have a much better cash register up here. This is a CPU, and the little cashier is like our CPU. And all of us, as we connect to that travel website, we are assigned to a thread. So, and each of the threads are assigned to the different schedulers or CPUs as well. And if I'm in line to get to purchase some groceries or whatnot, and all of my stuff is getting scanned, then my thread is running. So if you've ever done an SP who to, or looked at the activity monitor in SQL Server, you'll typically see all the threads, all the SPIDs, session IDs. You'll see them as either running, runnable, or perhaps idle or suspended. Everybody else who actually wants to get work done too, we're waiting to assign the city that we want to fly to or fly from, or the dates. We're waiting as a thread to get access to that CPU. If, however, the tag fell off, or in my case, maybe I'm trying to get a record that's currently locked by somebody else, and so I can't use it. Well, then that means go ahead and step out of the way. And I need to get that information. It's going to take you a minute to get your work done. So then someone else who's in the line gets to step up into their place. This person has to step out of the way, going into the suspended queue. These people, these threads, the runnable queue gets to move up. Yay! And they get their processing done. So that's how you can tell whether you're suspended, running, or runnable. These, if you're running or runnable, you accumulate weights, and or if you're suspended, you accumulate weights, and those fall into two categories as well. There's the resource weights, which are people in the suspended queue who have said, "Hey, I need access to a resource that I'm not getting. Maybe I need more network. I need more I/O. I need, I'm waiting for locks to be complete." And then there is the system, the signal weights, which says, "Hey, I signaled I'm ready. I'm just waiting for a shot at the CPU." And so you'll see different people offer sessions just on weight stats, how to interpret what weight stats are, because that tells you where all of your bottlenecks are inside of SQL Server. So another thing to talk about here are the buffer pools, and this is just a quick rehash, because most of us now are on 64-bit, I hope, and if you're not, you need to know the differences because it's a very important one. Let's say we've got two identical servers. The only difference is that one is 32-bit and one is 64-bit. They have the same amount of RAM. They both have 16 gig of RAM. Well, what happens is there's a whole set of limitations on the 32-bit side that don't exist on the 64-bit side. So the first thing you have to do is on the 32-bit side, you, by default, are able to set aside 32-bit can access 4 gigabytes of RAM. Anything over 4 gigabytes of RAM has to be configured using AWE. You could kind of tinker around with the amount of memory you have under 4 gigabytes. By default, SQL Server gets 2 and the OS gets 2. If you use the /3 gigabyte switch, you can get 1 gigabyte of that goes to the OS. You can give it to SQL Server, and that can make SQL Server a little bit faster. But anything over the 4 gigabyte threshold will need to be made accessible using addressable Windows extensions, AWE. So that will give us the other 12 gigabytes over the 4 gigabyte threshold. The only problem is anything over that 4 gigabyte threshold can only be used for data cache. So it cannot be used for all sorts of other caches that exist inside of SQL Server, such as the plan cache. There's things like sorting cache and hash cache and min to leave and different sorts of resource caches, extended events, stuff like that. So that means you can still experience plenty of memory pressure on a 32-bit system, even if it has 16 or 32 or 64 gigabytes of RAM. On the other hand, you compare that to 64-bit memory, and at least in the first generation of 64-bit processors, you could address up to 2 terabytes of RAM, and any amount of that RAM could be used for any purpose for SQL Server's processing. So it's a huge difference in memory processing. 32-bit systems also suffer from something called the give and take dichotomy, which is in order to reach data over the 4 gigabyte threshold, SQL Server has to, or I'm sorry, Windows has to build a little map, an addressable memory map to the data over the 4 gigabyte threshold. So the more memory you have over 4 gigabytes, the less you have actually under the 4 gigabyte threshold for other uses. And so you could actually starve yourself of the memory you really need on a 32-bit system by adding more memory. It's a strange situation, and one that is easily fixed by upgrading to 64-bit. Now, so we talked about how are these caches configured. Let's talk a little bit about how SQL Server handles the cache. And I made a horrible Tina Turner joke there, so if any of you are Tina Turner fans, I apologize. So what happens to SQL Server? How does it put memory, or how does it put things into that memory? Well, what SQL Server uses when it puts a 8K data page or procedure cache page into the cache, it uses an LRU algorithm, a least recently used algorithm. And this is maintained by the Lazywriter, but there are other things that can invoke it. But typically, think of this as something called the Lazywriter. I don't know why, but in my mind, I always think of a guy on a motorcycle, a hippie-looking guy on a motorcycle. I think it's because of this film in the 60s called Easy Rider. But anyway, it can be invoked by other things, worker threads, when they're doing their scheduling and so forth, but typically the Lazywriter. And so what happens here, let's imagine that we have a bunch of different stored procedures. Some of these are maybe just simple queries or inserts or updates, stuff like that. And the each of these different queries are compiled. And the queries and whatnot, when they are first compiled, they get two values assigned to them. The first one, let's say it's the one on the left, that's the complexity value. This is how complex it actually is. And again, it's kind of an arbitrary sort of idea. There's no specific chart somewhere out there in which SQL Server says that this particular action costs a certain amount. It's relative to each statement. But the SQL Server store procedure will say, let's say this one's 16 compared to this one, which is just a simple select statement, but this one has some processing that happens. And then the other number is the countdown counter, which is based on the complexity counter. So Sheldon is going to be our little Lazywriter here. About every minute or so, he'll wake up from the party he was attending, playing piano, having a drink and whatever, and he'll take a look around. If anyone has used this particular, any of these particular stored procedures, then he'll go to work. But if no one has used any of these stored procedures, he will go through and decrement the number, that complexity countdown number, on each of these different stored procedures. About a minute later, he comes back, takes a look around at everything in the procedure cache. If they haven't been used, once again, he'll go through and he'll decrement all of these different counters. And in some cases, some of these counters will reach a 0. So what do you think happens when one of these reaches 0? What is that? What happens there? Well, Sheldon will take a look around on his next pass, and if it reaches 0, what he will do is a little bit tricky, actually. The correct answer to most of your technology questions is always going to be, it depends. And so what he does is, if there is memory pressure, he'll go ahead and delete that right away. But if there's not memory pressure, it actually just gets marked for it's ghosted, is what it's called. So it's not actually truly, totally deleted. The idea being, well, it's ready to be deleted at the drop of a hat. Just give me the reason. Just tell me that somebody else needs that memory, and I'll drop it, reuse that memory immediately. But if there's not memory pressure, then I'll go ahead and let you leave it there just in case somebody wants it, so it'll be ready to re-invoke instantly. And here's some of our other ones. Might also have dropped to 0. But if someone uses that query or that transaction or that stored procedure, that counter will get reset back up to the value of the complexity counter that was initially set. The idea here is that the more complex it is, the less we want it to, the more time we want to give it before it gets pushed out of cache. If it's really small and really simple, it takes almost nothing for the CPU to regenerate that plan or to generate a new plan for it. So that's okay. We don't mind throwing those away frequently and then recompiling them frequently. But if they are used fairly frequently and they're quite complex, like let's say get order, well, we don't want SQL Server to throw those away very, very quickly. We want those to hang around for a while. So it's a little bit of a modified, least recently used. The idea being the more complex it is, the more time we allow it to stay in the cache. Now, that gives you a little bit more idea of what happens when we start to do lots of writing. operations, inserts, updates, deletes, and we're doing create statements, we're doing grants and revokes and things like that. So now let's say that we're going to go forward and actually book some travel. We're going to write it to the system here. So now we do the same sorts of things that we did just a moment ago. We say where we want to fly to, what dates, and now we want to save this to the database, so it gets wrapped up in the tabular data stream packages, which then also get encapsulated by the SQL network interface to go into TCP/IP packets. Those packets are received on the SQL Server relational engine port 1433. The parser takes a look at it. Do I understand this? Oh yeah, that's an insert statement. So now let me check to see if that insert statement is already in the plan cache. Not there. I'm going to have to build my own, build a brand new one. So now I have to go over to this side of the relational engine and figure things out. And I need to build a query tree, which will then get built into a query plan. Now just an aside here too, as we go much further. If you ever look at the query plan for, let's say, a delete statement or an update statement, one of the things that when I was first learning how to tune SQL, gosh, way back in the early 90s, late 80s and early 90s, was that the query plans, the execution plans, I guess you could say, for inserts and updates and deletes were always much, much more complex than those for select statements, which puzzled me because the way I would test the delete statement was to first write a select statement that would make sure that I selected only the records that I needed to modify. And I kind of puzzled over it and pondered it, and then I realized what it was. When you do a delete statement, or let's say you do an insert or an update, the primary thing that I tended to forget about was that tables are typically going to have lots of different constraints on them. Maybe they'll have a primary key that's also has a unique constraint. Maybe there's an identity column on it. Maybe there's some kind of default value on it. Maybe there's some foreign keys in there. There's some check constraints. All of those are like little miniature select statements. So each one of those also are included in the query, the execution plan of the insert, update, or delete statement. So when you have an insert statement or an update or a delete, it's going to have all of those other elements that check those constraints as well in the query, in that full plan. So it becomes much more complex. Not to mention that there might also be triggers on there and who knows what else. So that's one of the reasons why execution plans for write operations tend to be much, much more complex. So it's handed over to the query executor who packages the execution plan up into this proprietary little internal operation and hands that over to the access methods of the SQL Server relational engine for handling. But this is where things change a lot. What happens now is we really kick in on those ACID properties that we had talked about earlier. So remember, one of the first things it was the fourth acronym, but I mentioned it was the most important in terms of how much overhead it generates, and that is durability. So what happens in most all relational databases is something has to be written to the transaction log, whatever that might be. It's called an archive or a redo log on Oracle. All the other databases have their own name for it, but Sybase calls it a transaction log. And so there's actually an operation that writes to the transaction log before anything else changes anywhere in the relation, and anything else changes anywhere in the system. So the log manager is invoked. It writes this kind of hash of the transaction. You can't read it with a naked eye. And that little hash writes the full description of what the transaction is and needs to do there in the transaction log so that it can be either fully committed or fully rolled back. In fact, there are some good products out there, one of them from my company, Quest, that will let you read the transaction log and undo individual statements that might have occurred. Like, don't you wish you could do Control-Z in SQL Server, an undo like you can in Excel and Word. So there are some products out there that do that. Once it is successful, that transaction is successfully written to the transaction log, then SQL Server will actually take a look to determine where is this memory, or I'm sorry, where are the records that we need to change. Are they brand new stuff? Are we doing insert? Are they things that exist that we're changing with an update or a delete statement? So that's where the access methods then hands that off to the buffer manager. The buffer manager says, hey, I'm going to change some stuff here, and I need to make sure that I can actually get to it. And so this is the point at which SQL Server invokes the lock manager. And the lock manager determines who has priority access to those those records and elements of the database so they can make changes. And once again, if the data pages, the records that we need to change, are somewhere in the data cache, life is going to be so much faster. We don't have to go and retrieve those data files, the data, the AK data pages, from the disk and then load those in the memory. But if they aren't in the data cache, yep, we have to grab them and put them up in the data cache. And then we change them there. But here's another important difference that a lot of people kind of lose track of. The data pages that have been changed are only changed in memory. At the moment they have, the moment that they're changed, they have not yet been written back to disk. And what is a data page that is different in the cache? What is that called compared to one that is written to the disk? Well, that is a dirty page. And so you'll see lots of kind of recommendations that tell you not to allow dirty reads because this stuff hasn't been written yet. A dirty read is when we read what's in the cache. We're not reading from what's possibly or probably on the disk. And so, hey, you may be seeing results that aren't committed, that aren't truly part of the system. Maybe will get rolled back, and vice versa. Stuff that has been changed. And so you're going on what's in memory, and it may not be what's actually going to be the running values, the fully committed values. So we got these nasty, dirty pages in the data cache. Now what happens is, way back when we started out and talked about the reasons for the way these architectures are constructed back here, the internals, the reasons they operate the way they do, is that we want to cache up all of these different writes and send them in a big bunch down to the data file. So this is an example in which we're trying to maximize the capability of the hardware. And SQL Server uses a process called a checkpoint. In fact, all the relational databases do. It's part of the ANSI SQL standard. And so the checkpoint, by default, is going to happen once every minute. And that's based on the SP configure setting called recovery interval. And what that says is once a minute, I want you to go through in a process very much like the Lazywriter and look for dirty pages in the data cache and then flush those to disk. And when you do that checkpoint, that's going to flow all of that data out in one big stream out to the hard disks, and the hard disks will write all of that out. There's a little bit of a misunderstanding about checkpoint, I find frequently. For example, by setting that recovery interval value to something other than 1, that indicates basically the number of minutes you want SQL Server to wait before it will naturally take a checkpoint. So if you change it to 5, for example, SQL Server would wait to do a checkpoint for 5 minutes. And that's the reason they call it a recovery interval. Because if lightning hits the server that this buffer pool resides on, and we have 5 minutes worth of transactions that are dirty in the data cache, the only way to recover that information is to read those from the transaction log. Because remember, that happens first before anything else happens. So it might take 5 minutes or more for your SQL Server to recover all of those transactions when you were to do a new startup. So if you've ever done a startup on your SQL Server and you've seen where it lists off all these rolling back or rolling forward transactions, messages, when you do a startup, that's based on SQL Server using the transaction log to recover dirty reads, or I'm sorry, dirty writes to the cache, and all these things that have been written to the cache but hadn't been flushed to disk. An interesting story I like to tell about a friend of mine who worked for a very, very large printing company that printed many of the USA's most popular glossy magazines like Vogue and Glamour and GQ and stuff like that. And they had a printing process that was controlled on the back end by a SQL Server relational database application. And when they would change a roll of paper on these printers, it was just huge. It was, it's taller than you could reach up. A tall man could reach up probably 7 or 8 feet. And the diameter of these rolls of paper was bigger than that. And when they were trying to get this system operational, they would start the printing process. And the printing process was so fast that if an operator noticed that maybe the paper was tearing or twisting or knotting or something like that, and they walked, the time it took for them to notice that, to walk back to the operations booth and turn off the printing process, they would actually have used up pretty much that entire roll of paper. That's how fast it was. Just huge amounts of printing done in very, very short amount of time. And the problem was the SQL Server application would just kind of keel over. And what they discovered was it would begin to, they would begin to print if SQL Server was, streaming all of that data. It was keeping up well, but that's millions of transactions per, per minute, as things were, thousands per second, tens of thousands per second. And then SQL Server would do, after a minute, it would do its checkpoint. And it would get way behind in flushing data to the data file. And then SQL Server would continue to process, and it hadn't yet finished its first checkpoint before the next checkpoint had happened. And so it wasn't able to keep up. And so it would cause the I/O to get saturated and then basically fall over. So what they said was, hey, we actually stop this process pretty frequently to change out these rolls of paper. So why don't we change this checkpoint interval, the recovery interval? So another thing that a lot of people don't realize is that you can actually just issue the checkpoint command just like any other SQL statement right there from the prompt. And so that's what they started to do. Every time they changed a roll of paper, they would just do a checkpoint. And eventually that became automated. But once they had figured that out, the system had plenty of time to flush everything to disk after a checkpoint. So it operated very quickly and very effectively. And so once things are finally flushed back out to disk, SQL Server is then able to say, hey, all right, your transaction has completed. And you get that little message at the end of your, well, a lot of websites and applications will filter it out, but if you're sitting there using Management Studio, for example, at the bottom, you will notice it will say something like, 14 rows affected, or something of that nature. And so that's when you get the confirmation that your transaction has completed. So that's how the internals of SQL Server works. We've got our interface, we've got the protocol layer, goes over to the relational engine. The storage engine then handles a great deal of that work. That's kind of the heavy lifting, and it's answered from the buffer pool or from the transaction log in the data file. So let's review. And also, if you are interested, you could type in some questions in the chat, and we'll get to those questions in just a moment. But let's review. I really feel like understanding the internals of the system is the foundation. It's every bit as important for you as it is to know how to write a good select statement. Some very important things to remember. Those ACID properties of transactions, they influence everything else inside of a relational engine. Atomic, consistent, isolated, durable. And you don't get those guarantees when you're working with other kinds of systems that are not relational. What are the key components of the relational engine? Remember, there were the three boxes inside of the relational engine. Those were the command parser, the optimizer, and the query executor. How about the key components of the storage engine? Again, those were the access methods, the buffer manager, and the transaction manager. How about the key areas of the buffer? Of the buffer pool. They're both called caches. We've got the plan cache and the data cache. And there are also several other smaller caches out there. If you ever want to make use of those or look at those, there's a DMV you can use called sysdmos memory clerks. Just Google on memory clerks for SQL Server. It will show you all the different little caches that exist inside SQL Server. So the main ones are the plan cache, the data cache, but there's many, many other smaller ones. And then don't forget the key areas of the transaction manager. The log manager, that's for the transaction log, and then the lock manager that handles all the locking and blocking kind of handling that occurs inside of SQL Server particularly for the write operations. Also, don't forget those key processes. The Lazywriter, which in particular handles cleaning up of the plan cache, and then the checkpoint, which cleans up the data cache and flushes all of those dirty pages out to the disk. Okay, let's talk again about a little more info. As I mentioned before, got lots of posters and things like that for you from that I've written at Quest. So if you want the Perkmon counters or the system stored procedure guide or the DMVs, or some of that training information I told you about there, it's about 8 hours of video training. You get those at these URLs. Also, just going back one step here, I would encourage you strongly to add a couple blogs to your list. The first set of blogs that I would encourage you to look at, if you haven't already looked at them, is I always recommend that people look at SQL Cat. SQL Cat is the SQL Customer Advisory Team, and they're at SQLCat.com. These are kind of the ninja, warrior, Jedi Knight of the Microsoft support group for SQL Server. Extremely well versed in SQL Server, probably the most knowledgeable SQL Server people in general that you're going to find out there. They write most of the white papers that you'll find on TechNet or on MSDN, and they have great top 10 lists. They have great mini white papers. They have great resources and scripts and things like that at SQLCat.com. Some other blogs I would encourage you strongly to look at include SQLskills.com. This is the website where Paul Randall and Kimberly Tripp write, as well as my buddy Jonathan Cahias. And so Paul is the former lead of the storage team at Microsoft. He holds the patent for DBCC. And the blogs that Kimberly and Paul put out are just second to none, just outstanding blogs, very, very good. I also recommend, about a half a dozen other people. You could look at my own blog to see who I blog roll. My blog is at kevineklein.com. Or you could take a look at some of the aggregators like SQLblog.com, SQL Serverpedia, SQL Server Central. Those are all very good. SQL Team is another good one. And take a look at those. So there's some excellent blogs out there. I think right off the top of my head, I would encourage you to take a look at SQL Skills, SQL Cat, and let's see, another one of my blogger friends that I like a lot is Glenn Berry. Writes some excellent stuff on, particularly on DMVs and queries that you can reuse, just great script libraries that he makes available to you. And then I really like Grant Fritchie's stuff. Gosh, there's quite a few I could list, but let's start with those. If you're interested in getting slides from my other sessions as well as this one, you can go to kevineklein.com/slides. I'm the editor-in-chief at SQLServerPedia.com, so I hope you'll take a look there. I also write a column called Tool Time for SQL Server Magazine, and I hope you'll take a look at that. I write about free tools from the SQL Server community. And finally, if you are not yet on Twitter, I do encourage you to get active on Twitter. A lot of people say, I don't need Twitter. It's people telling me what they have for lunch or something like that. I don't care about that. And you're right not to to care about that. But the things that most people don't realize is there's something called hashtags, which is kind of like a TV channel. You can go to the Learning Channel or the Discovery Channel or something like that. So hashtags, you can subscribe to certain channels of discussion. You could subscribe, for example, to DBA or hash SQL or hash SQL Server. And one that I recommend to people who don't really want to use Twitter except for work-related things is you can subscribe to a channel called SQL Help, hashtag or #SQL Help. And this is where quite a few SQL Server experts hang out, And you can throw a question out to SQL Help, and typically you're going to get an answer within about 20 minutes or so. So it's really unusually helpful. I'm surprised at how helpful it is. So that's on Twitter, and the hashtag is SQL Help. I encourage you to take a look at that. And if you are on Twitter, perhaps you'll consider following me and all the tweets and stuff that I do. So with that, we have just a few minutes left. I'd like to go ahead and hand it over to Rachel. Rachel, how do we go about with Q&A?
Yes, I can read them out loud to you if that's fine. We have a question from William.
Oh, absolutely.
Is that good? Okay. We have a question from William. When and how does a query get the plan cache?
Okay, if we, let me see here, I'm going to drop back.
See, it's like the butler from Mr. Deeds.
So a query will attempt, let me go back in time here, a query will attempt to answer from the cache. Now, I said the plan cache, so I'm trying to make sure I get this right. What it will do is it'll take a look at here in the optimization, just between the command parser and the optimization. So right in between those two steps is where it will attempt to see if it already exists out in the plan cache. So and this is why parameterization is a really important concept in SQL Server. If you write your queries in such a way that SQL Server can't figure out that it's actually pretty much the same as the last one that came through, then you could have two essentially identical queries, except that one, asks for you to look at Toledo and the other one asks for you to look at Cleveland. But it can't tell that because of the way it's parameterized. So it might create a new plan for that. So if you're having troubles with things getting called frequently enough in the plan cache, do a Google for like query parameterization, and make sure that you're following the rules for parameterizing your queries. If it looks right after the command parser step and doesn't see it, the text well, it's not actually the text, it's called a query thumbprint. If it doesn't see the query thumbprint in the cache, then it goes on and creates a whole new query plan, and then it gets loaded into the cache at that point.
Okay, great. And we have, and I want to apologize ahead of time, we do have quite a few questions. We're not going to have time to answer all of them, but I believe you had a slide up with your contact information, so maybe if we don't get to everyone's questions, they can email you for a follow-up.
Oh, absolutely. Yep, absolutely.
Okay, so here's another question from Michael. How does Buffer Manager identify that cache contains up-to-date data?
Okay, how does it determine that it contains up-to-date data?
Mm-hmm.
So the buffer cache, I talked a lot about the plan cache. The buffer cache is a little bit more, it uses an LRU algorithm, but it's a lot more complex than what we have in the procedure cache. So the procedure cache, it creates this complexity counter, and about every minute or so it checks to see if it's been used. With the buffer cache, it does that, but it does a lot of other things too. So there's all kinds of other if this then that sort of stuff. For example, if if a particular table is cached and it's really big, like over, I forget the threshold, like over 4 gigabytes in size, then it's a whole different set of rules kick in. Conversely, if the table is really, really small, another set of rules apply. If a table is small, for example, even if you have an index, SQL Server will always do a full table scan and will always load the whole table into the buffer. Simply because it's so small, it's just easier to do that whole other, just to load that whole thing in. And then there's also what's called a read-ahead process. So there are situations in which SQL Server sees that we're probably going to get more data than we're currently asking for with this one simple operation. So let's read it all ahead and grab it in 64K chunks instead of 8K chunks. So it's similar. It is a LRU algorithm, but it's much more complex than a procedure plan agent.
Okay, great. We have another question from Tejas. Where do global and temporary tables data store?
Where do global and temporary tables, where do they get stored? Well,
Right.
yeah, that's a tough one. The SQL Server rules change with the versions. So, but global and temporary tables always go to TempDB. There's a lot of questions about like variables, and also particularly on table variables. Where do those get stored? And at the SQL Server 2005 release, there were many situations in which they would be instantiated in memory. But with SQL Server 2008 and SQL 2008 R2, those also pretty much always get spooled out to the TempDB. So the general rule of thumb, if you're running on 2008 or higher, is count on your variables, even table variables, and your temporary and global temporary tables, pound and pound table. All of those go to TempDB. And that's why TempDB needs to be tuned just as much as any other operational database.
Okay, wonderful. Well, unfortunately, that's all the time we have for today. And as always, the session is recorded, and it will be made available on our website under webinars and past webinars by the end of the week. So thank you so much, Kevin. I really appreciate it. It was a great session.
Very much appreciated, Rachel. Have a great day.
Thank you, everyone, for joining us.